Okay. So Virisha, center of gravity is basically defined as a point where all the weight of the body appears to act. Now, basically, it means that writing this word is very important. So do not forget that this is a keyword here. And remember that center of gravity can also be outside the body as well. So it doesn't mean that it has to be within the body, it could also be a point that's outside, right? Now, so for regular shapes, for regular shapes like a square, maybe a rectangle, maybe a triangle and a circle, what you got to do is that you got to make line of symmetry. So when you make a line of symmetry, it basically cuts the whole thing into a half. You can make line of symmetry on the other side as well. When the line of symmetry meets, basically that point where it meets is the point where the weight seems to act, and that point is called the center of gravity. Is it clear, Varisha? Okay. Cool. Right. Now, the other thing is that we can do the same thing with the.
Sorry, is my.
Sorry, come again. Varisha, I think you're lagging. Okay. Waiting.
Is my voice clear now?
Yes, yes, it is clear. Okay. So, Varisha, then when you make like this for the rectangle, you can also make the line of symmetries. So the weight is here, and that is the center of gravity. Okay. Now, for a triangle, you can basically make through the vertices. And if you make a line through the vertices, that line will meet somewhere, and that would be the center of gravity, where the weight will act. For a circle, you can just go through the diameters, where it meets exactly at the center. That would be the center of gravity. Is it clear? Okay. Now, the real issue is that sometimes the shapes aren't regular. And if the shapes are not regular, see, wait a second, please. So for that, we basically you don't need to do any experiment for that. We'll do it in unit 3. But the thing is, you just need to know that usually we put that shape onto a stand or something. Okay, like that. And you basically pin it from here. You pin this on that stand, okay, from some point. And now you're basically applying a force right here. And because the pivot is right here somewhere, so you got, a perpendicular, like this is where the line of action of the force is. And of course you are at a certain perpendicular distance, right? So basically it is causing a moment here. Okay, now what happens is that we understand, okay, there is a perpendicular distance, force causes it to rotate like this. But the thing is that the moment you basically leave this, wait a second, let me fix it. So the moment you leave this, because it has certain center of gravity where the weight is acting, the weight too has a perpendicular distance till the pivot, which basically means that this object then adjusts itself like this. So it moves in this direction, anti-clockwise, and it only stops when the weight or the center of gravity is aligned with the pivot. Is it clear?
Yes.
Okay. Now, so why center of gravity is so important? Because of two things that we're going to talk about right now. The first thing is the use of it in energy questions. So suppose there is a box. Let me write it here. And this box has it is 4 meters from this side and 2 meters from this side. And because it's a regular shape, so we already know that center of gravity is somewhere in the middle, which is basically 2 meters from here and about 1 meter from here. Is it clear, Varisha?
Yep.
Now, in the question, this object basically falls on the other face, okay, like this. So now this part is 4 and this is 2. First it was standing on 2. They have given this distance of the height of this, you know, place as 3 meters. Is it clear?
Yes.
Now, not 3, my bad, 30 meters. Now, first of all, they say that what is the height of center of gravity after falling to the ground? Can you please tell me this?
Is that 1 meter?
1 meter, that's correct. Because it would be at the center, this would be 1. So that's 1 meter, fine. Now, in the next part of this question, they say calculate the loss of gravitational potential energy if the weight of lock is 500 newtons. Okay. Do you understand this? Can you please tell me? Can you find this? You know mgh is the formula, right?
Does this mean the block at the center of gravity or the big block?
It just says calculate the loss of gravitational potential energy when it falls like this. Just that.
So would it be 500 into 9.8 into, I'm assuming 2?
2. Right? It doesn't fall like from 30 meter from above. Why 2 then?
So 34?
34. Okay, you're assuming because of the center of gravity. Okay. No, that's not correct. Marisha, you need to understand that, and this is why it is a trick question. Most of people get it wrong. The thing is that the weight acts from the center of gravity, which is here, right? And when it had fallen, the weight now acts from here. So basically, it has the height of this force has changed from the center of gravity before till the center of gravity now, position this way, right? Is it clear, Varisha? Now if you notice, right, this height, the total, if we get the total, it's 30 plus 2, 32 minus 1. This is 31 meters. Do you understand?
Yeah.
Now, mg is already the weight in the formula, so that's 500. And the height is 31. Now you just need to bring out calculator. And that is going to be 15,500 joules. So what we learn here is that basically always take the height from center of gravity to center of gravity. Is it clear? You're not supposed to take it from any other point, and that would basically be wrong. If we had taken it from, most people, what they do is they're like, okay, it has fallen 30 meters, so let's take 500 times 30 because that's the change. So they end up with a pretty different answer, Do you understand? So that is wrong then. Any questions now?